This series of videos is going to look at factorising exponential expressions. This is when we look for common factors in all the terms of our expression and take them out to make a simpler, shorter version of what we originally started with. Now, all the exponent laws we've practiced in class are very important, but I quickly want to remind you about two of them which are going to be exceptionally useful when factorising exponential expressions. The first one is when we have a power raised to the power, which we describe as a base a raised to the power of m, all raised further to the power of n. Here I've got the example of 5 raised to the power of 2 raised to the power of x. Now, because the exponents m and n are going to be multiplied by each other, the order in which they're positioned doesn't matter. So, what we see here is 5 to the power of 2 raised to the power of x is equal to 5 to the power of x raised to the power of 2. I've simply changed their positions around. But again, all we're doing is multiplying them. So what we have here at the beginning is simply 5 raised to the power of 2 raised to the power of x is also equal to 5 to the power of 2 times x. So again, this is power raised to a power. The other one is when we have exponents with different bases, but the same exponent. So here, for example, I have 3 raised to the power of 5 times 7 raised to the power of 5. When we have a case where the exponents are the same, what we can simply do is multiply together the bases and raise them to the same exponent. So what I have here is 3 times 7 raised to the power of 5. So what we have at the beginning is equal to 21 raised to the power of 5. So again, just going over some key things we did in class. Let's solve some problems together. First of all, we want to factorise 3 raised to the power of 2x plus 3 to the x. So again, we know x plus x is equal to 2x, and we can add together exponents when they're being multiplied together. So this means here 3 to the power of 2x can be rewritten as 3 to the x times 3 to the x. Now in both my terms, I have a common factor of 3 to the power of x, which I can take out of my expression, giving me 3 to the power of x times everything inside the brackets, which is 3 to the x plus 1. Factorisation is done. Let's try the next example. Here I have 5 multiplied by 2 to the power of n plus 2 to the power of n plus 2. Again, as we said, when we're multiplying exponents with the same base, we simply add their powers together. So this second term here can be rewritten as 2 to the power of n times 2 to the power of 2. Now again, if we look at these terms, we see the common factor is again 2 to the power of n, which we can take out of both terms. This then gives us 2 to the power of n outside 5 plus 2 squared, which is simply 9. So what we have here can get factorised down to 9 times 2 to the power of n. Next example. Here we have 2 raised to the power of n plus 1 plus 3 times 2 to the power of n plus 2 raised to the power of n minus 1. Let's focus on the first and last terms first. So again, these parts will be rewritten as 2 to the power of n times 2 to the power of 1. Because again, when I multiply them together, I can simply add the exponents. So this part over here becomes 2 to the n times 2 to the negative 1. Now what I'm going to do is I'm going to turn all those into numeric terms. So 2 to the power of 1 is 2, 3 stays the same, and 2 to the power of negative 1 is simply a half. As we can see, the common factor is 2 raised to the power of n. We can take all that out, giving us 2 to the power of n plus all these values, which is 5.5 times 2 to the power of n. But we can actually go a little bit further. 5.5 can be rewritten as 11 over 2. But now again, what we have is this part here and this part here have the same base. This is 2 to the power of n. This is 2 to the power of 1. So using our quotient law, which we've learned in class, this can be rewritten as 11 times 2 to the power of n minus 1. Again, equal to what we have here at the beginning. Last example. Here we have 4 to the power of m plus 8 to the power of m divided by 4 to the power of m. Now, 4 to the power of m divided by 4 to the power of m can divide through to 1. But 8 to the power of m isn't quite as simple. So first of all, we rewrite 8 to the power of m as 4 to the power of m times 2 to the power of m. Like before, same exponents, different bases. 4 times 2 equals 8. Again, we can see the common factor between all the parts of our equation is 4 to the power of m. We take that out. That then gives us 4 outside the brackets of 1 plus 2 to the m divided by 4 to the power of m. These two divide through to equal 1, leaving us simply with 1 plus 2 raised to the power of m. As you probably can see, we're not doing anything different. We're just applying the index laws in one way or another to find a common factor. The next set of factorization videos about exponential expressions will actually be using perfect squares or a difference of two squares, which is simply a way of identifying a pattern within our expression to quickly find the factors so we can break it down and simplify it very fast. Remember, the key part to these videos is that you watch them at home, take notes, and then come to class and ask questions if you're not sure.